Hello student, I am Kiran Kumar from Nature of Physics. Today topic is spherical mirror. First one is concave mirror is a converging mirror, and second one is convex mirror is a diverging mirror. Please do like and subscribe our channel Nature of Physics. See there. First one diagram is the object at infinite distance, the parallel rays releasing and incident on the concave mirror, always parallel rays passing through the principal focus. Okay, see there, the object at infinite distance, student. So the parallel rays are passing through the principal focus, so that real and inverted point size image form at the principal focus, so that h dash is taken as image height. Image height is very much less than to the object height. H represent the object height. Okay, and next one, second diagram, considering parallel to that first one. So first one is their parallel rays are parallel to the principal axis. Now here also parallel rays, but not parallel to the principal axis, making some angle. In this situation also object at infinite distance, again real and inverted, very small image form at the principal focus. See, the ray passing through the principal focus after reflection parallel to the principal axis, student, and the ray passing through the center, there is no deviation. Okay, so that we are getting real and inverted, very small image at the principal focus. Okay, and next one, second one we will discuss, student. Here the object is between at infinite distance to the center of curvature of the concave mirror, and the rays releases and incident on the concave mirror, and the parallel ray passing through the principal focus, and the ray passing through the principal focus after reflection parallel to the principal axis, both are coincide at one point, that give the real and inverted, very small image between the center of curvature and principal focus. See there, whenever the object is at infinite and center of curvature, and the image we are getting real and inverted, small image between the center of curvature and principal focus, student. Clear diagram. And one more thing we have to discuss about here, concave mirror focal length is concave mirror focal length is negative. Okay, and here I can represent focal length is minus f, student. Distance between the pole and the principal focus is taken as focal length. For concave mirror, focal length is equal to negative. Okay, because of according to the sign convention, so P is taken as center, so this is taken as negative x-axis and this is taken as positive x-axis. Heights above the principal axis is positive, heights below the principal axis is negative. See there, height above the principal axis is positive and height below the principal axis is negative. So this is image, student. Okay, this is object O, image is I. Okay, and next we will discuss there the concave mirror, in which the focal length representing with respect to pole along the negative x-axis, and focal length distance is away from the incident ray. The distance along the incident ray is positive, the distance opposite direction to the incident ray is taken negative, student. And in the continuation diagram also I will explain about the sign convention. Okay, so now second already we did, in which here object height is positive, image height is negative, because of object height is along the positive y-axis and image height is along the negative y-axis, and this is taken as pole and this is taken as positive x-axis and this is taken as negative x-axis, so that here object distance is negative and image distance is also negative, focal length also negative, student. Already I gave you for concave mirror focal length is negative. See there, the distance of the object is opposite direction to the incident ray, the distance of the image also opposite direction to the incident ray with respect to pole, student. So simply remember, so along the negative x-axis with respect to P point, distance taken negative, so that here object distance, image distance, focal length 3 are negative. And next one, third diagram. Now the object is exactly at the center of curvature, student, so that light ray is releases and the parallel ray passing through the principal focus and the ray passing through the principal focus after reflection parallel to the principal axis, and here we are getting real and inverted image, same size image at the same place, center of curvature. So whenever the object is at the center of curvature, we will get the real and inverted image at the same place, okay, with the same size, okay, so that image height is equal to object height here. So image height is less than to the object height, student. Image height is taken h dash there, okay. And next one, here I am going to write image height is taken as minus hi, object height is taken as h naught. H naught is positive and hi is negative because of negative y-axis representing image direction and object is representing along the positive y-axis, that is heights above the principal axis is positive, heights below the principal axis is negative. And next one, fourth one we are discussing. Now the object is between the center of curvature and principal focus, student. So for this diagram, the parallel rays passing through the principal focus and the ray passing through this principal focus after reflection parallel to the principal axis, and that here we are getting real and inverted enlarged image beyond the point C, center of curvature. So whenever the object is between the center of curvature and principal focus, we are getting real and inverted enlarged image, magnified image, that is at a point C, student, okay. In this condition, image height I am considering h dash is greater than to h, so that image height is taken as minus hi, object height is taken as plus h naught. Object height is above the principal axis is positive, image height is below the principal axis is negative, and object distance also negative, image distance also negative, student. Even focal length also negative, already I gave you. Concave mirror focal length is negative. And next, fifth diagram I am going to explain. For the fifth diagram, see there, object is exactly at the principal focus, student. See there, object is at the principal focus and image from the at infinite distance, student. Infinite distance, that is what type of image we are going to get? Real and inverted, very enlarged at infinite distance. So we are observing from here, this is considered like a eye, student. So here image height is very much greater than to the object height, and real and inverted very large image form at infinite distance when the object is exactly at the principal focus of the concave mirror, student. Now here we are going to get the virtual and erected image when the object is between the principal focus and the pole, student. See there, here this is the object and light rays releases from the object incident on the mirror, concave mirror, and reflected passing through the principal focus. In the concave mirror, the parallel rays reflected and passing through the principal focus and the ray passing through the center, and it is retrace its path in opposite direction, student, so that extended this rays and give the image, student. This is image height is plus and object height is also plus, student. Object height is taken h naught and image height is taken hi. So image height is taken h dash here. H dash is very much greater than to h for the concave mirror when the object is between principal focus and the pole. Now here we will get virtual and directed enlarged magnified image behind the mirror, student, behind the mirror, so that here object distance is negative and image distance is positive. Focal length already we know that should be negative, student, because of it is a concave mirror, so focal length is negative. This is the object distance is negative, okay. Next we are discussing about the convex mirror, that is diverging mirror. Here we will have three diagrams, okay. See, student, okay, 1, 2 and 3. So for first one, object at infinite distance, the parallel rays are considering, student, and second one is that is also object infinite distance, but parallel rays making some an angle with the principal axis. Students, see, making some angle with the principal axis. See there, for this convex mirror object at infinite distance, parallel rays are passing through the principal focus, reflected rays are extending, so that give the image at the principal focus. The image is virtual and erected point size image at the principal focus. Okay, when the object at infinite, parallel rays incident on the convex mirror, which type of image form there? So that is virtual and erected point size image we will get at the principal focus. Student, clear diagram is given. Okay, and next one is here the rays making an angle with the principal axis. The rays are parallel rays, and the ray passing through the principal focus after reflection is parallel to the principal axis, and the ray passing through the center, there is no deviation, retrace its path. Okay, so that extending that reflected ray and give the image. This image is also virtual and erected, very small image. Student, okay, and that h dash is less than 2h, and representing next one is, this is the focal length. Focal length is positive. Student, okay, here writing convex lens, focal length is positive. Okay, and next here getting the image position. Student, image position is representing like this: image distance with respect to pole, this is the image distance, plus v. Student, so magnification, this is very small point size virtual and erected image form. Okay, so that I'm not discussing about the magnification. Next we will discuss about the magnification for the condition the object is in front of the mirror. Student, so that is what type of mirror? That is convex mirror. Convex mirror. Okay, so this object distance is taken as negative because of along the negative x-axis, and this image distance is taken positive. Student, and focal length also positive, plus f writing. See there, derivation I am considering for this second case. Student, so the object is in front of the convex mirror, so the parallel ray passing through the principal focus. Student, so that reflected ray passing through the principal focus, extending and coincide at a point f, and next one the ray is passing through the center of curvature and get reflected along the same path, and both rays extended coincide at point that give the image. Student, so this image is taken as plus hi. Student, image height is plus here because of height is above the principal axis, and here also object height is plus. Student, above the principal axis, but image distance also positive and object distance only negative, representing along the negative x-axis, so that